Hi guys, welcome to the new tutorial on Java and Android multi-threaded programming 3. In the earlier two series of the tutorial, we learned about thread pool executor, we learned about callables, runnables, tasks, countdown lash, and we designed our model for concurrent programming special problems. In this tutorial, we will be learning about synchronization, monitor, and logs. If you have not watched the previous two tutorial series, then I recommend you to watch them after this tutorial. This tutorial does not require any other concepts apart from what described in this tutorial. So let's move forward with this tutorial. Now we will understand synchronization. The first thing is Java helps to achieve the access of one resource by one thread at a time. In the diagram you can see that we have a resource and there are 5 threads wanting to access the resource. When one thread is running and has access to resource, other thread will wait for their turn. To understand synchronization, you will have to understand the concept of monitor. Because in Java, synchronization takes place with the help of monitor. The concept of monitor is similar to that of an ATM machine. In the diagram, you can see that we have an ATM machine and we have a queue of people. So when one person has access to the ATM machine, the other people wait for their turn. The person who has access to the ATM machine can carry out his operations, and after he leaves, the other person in the queue can then access the ATM machine. So this is what synchronization means, that we are synchronizing the access of resource to various persons who are trying to work on the resource. So let's see what is a monitor. In Java, monitor is an object that is used as a mutually exclusive lock. We will understand what a lock is further in this tutorial. Only one thread can own a monitor at a given time. All the other threads attempting to enter the locked monitor will be suspended until the first thread exits the monitor. A thread that owns a monitor can re-enter the same monitor if it desires. In the diagram, we can see we have a monitor and a thread is running and has entered the monitor. Other thread which are trying to enter the monitor will have to wait till the first thread exits the monitor. So how does monitor help in synchronization? In Java, all the objects have their own implicit monitor associated with them. Okay, by default, all the object has a monitor. To enter an object's monitor, we will have to call a method which is modified with synchronized keyword. That's so simple to enforce synchronization by using a single keyword synchronization. To exit a monitor, the owner thread simply returns from the synchronized method. Once a thread enters any synchronized method on an instance, no other thread can enter any other synchronized method of the same instance. Non-synchronized method of that instance will continue to be callable. So in an object, all those methods which are modified with synchronized keyword will have a single access to one thread. So there are two modes of synchronization. One is method synchronization and another is block synchronization. In method synchronization, we just have to use a keyword synchronized. It can be used with both static and non-static method. And in the block, we can synchronize any block passing the object reference which has the monitor. Now the question is when to use synchronization. So the rule of thumb is when you have a method or group of methods that manipulates the internal state of an object in a multi-threaded situation, you should use the synchronized keyword to guard that state from the race condition. Now in part 2, we will try to understand how the synchronization help us resolve some of the programming problems and see them in action. I will encourage you to watch this tutorial on setting up a Java project using Gradle. The link to this tutorial for project setup is in the description. Hi guys, welcome to the part 2nd of the tutorial on Java and Android multi-threaded programming 3. In the last part, we learned about synchronization, monitor, and the need for synchronization. In this tutorial, we will go through a live example to understand the implementation of synchronization in the Java project. So let's move forward with this tutorial. Now I will create a Java project using Gradle. I'll go to my desktop, create a directory and call it Mindocs Multithreading 3. I'll go to that directory and create a Java project. Now I will rename this class for readability as main. Now I will create a public static main method that will act as a starting method for my application. Main string array args. Now, in order to understand synchronization, what we will do is we will create a resource class. Let's create a resource class. Now, this class will process a request to the resource as long as it is allowed. So at any time, this resource could be set to disallow processing. So one thread, while it is processing, another thread can disallow the processing. So in order to maintain the synchronization of read, write or processing, we will use synchronization. Let's see it in action. So this resource will allow processing and disallow processing using a flag. I'll call it disallow flag. So I'll create a variable called of type atomic boolean. I'll call it disallow. I've used atomic boolean because it is an atomic operation. So read and write operation happen in a single instruction. So it will not happen that while it is being written, it can be read by other threads simultaneously. So this disallow variable will define if resource read and write is allowed or not. So I'll expose a method that will set this disallow variable to true. And what it will do, it will make disallow set true. Now I'll create a method. I'll call it process. So this process, what it will do is, if it is allowed to process, not disallow, don't get, then it will process something. In order to simulate this processing, I'll cause the thread which is executing this method to sleep to 2 seconds. I'll have to handle the exception here. So after it wakes up, it will print that it has processed. Okay, it will print that I processed because it was allowed. Similarly, if it is disallowed, then it will print I could not process because it was not allowed. Okay, so what I have done here is that this resource created a flag which handles whether its processing is allowed or not. So there is a method which makes it disallowed. It has a method process. When it is allowed, it goes and does something. Here it does nothing, but it just sleeps for 2 seconds. After that, it prints that it processed successfully because it was allowed. If it is not allowed, then it will print that I could not process. Okay, now in the main method, I'll create a resource. Okay, now I'll create 2 threads. One will process and another will make the resource disallowed. Okay, thread t1 equals to new thread and pass a runnable to it. Similarly, I'll create another thread called t2. Now the first thread, it will process the resource. Okay, and the second thread will make it disallowed. Okay, now I'll start the first thread. I'll start the second thread. Now the main thread starts executing this main method when the program runs. It creates 2 threads, t1 and t2, and then starts the thread. Then I'll have to keep the main thread in paused state while both the t1 and t2 has stopped. In the earlier tutorials, you must have seen that I did this using a flag which helped in keeping the main thread alive, and after the flag was set to false, the main thread used to exit. So now I'll use the low level thread synchronization. I'll call join method of the thread. Similarly, I'll call t2.join, and will have to handle the exception. Okay, Now T1.join will make the main thread wait till T1 returns. Similarly, T2.join will make the main thread wait till the T2 returns. In the last, I will just print out that the program has terminated. Okay. Now let's see what happens when I run the main method of this main class. Yeah, so let's also print a message which will say was it allowed or not actually. Okay, and also let's print a message that will say that the processing is disallowed now. And now let's run this method. Now when you see the log, it says processing disallowed now, and then it said I processed because I was allowed, and disallow.get was true. It means that it was able to process even after its value was set to disallow. So in order to solve this problem, that when I call process, the value of disallow should not change until I have processed. So I will add a synchronized keyword to this, and similarly for disallow. So what I have done is I have made process synchronized and set allowed synchronized for this resource object. So when the first call thread1 t1.start, it will call the process, and when the thread 1 is into the processing, thread 2 cannot call disallow method because the monitor is taken by the first thread. When the first thread exits, then second thread will be able to set the value of disallow. Let's see the output now. Now the output is I processed because it was allowed and disallow was false, and after that processing disallowed now, and the program terminated. So first thread was able to process the process method, and after that only the second thread was able to set the value. So this example explains the use of synchronization in order to maintain the internal state of object consistent. In the next part we will understand about locks. So let's move to the next part. Hi guys, welcome to the part 3 of this tutorial on Java and Android multi-threaded programming 3. In this part we will learn about locks and how locks help in synchronization. So let's move forward with this tutorial. Before moving to the logs, there is a special condition with monitors and also with logs which is called deadlock. So deadlock is a condition when two threads have circular dependency on a pair of synchronized objects. As in the figure you can see that there are two threads X and Y, and there are two resources A and B. Thread X takes the lock of resource A, and thread Y enters into the monitor of resource B. Now X is waiting to enter into the monitor of resource B and Y is waiting to get into the monitor of resource A. So both will be locked. This condition is called a deadlock. It is difficult to debug the error of deadlock because it occurs very rarely when time slice is just right, and it may involve more than 2 threads and 2 synchronized objects. Now let's understand lock. So lock provide an alternative to the use of synchronized methods. Before accessing a shared resource, the lock that protects that resource is acquired. When access to the resource is complete, the lock is then released. If the second thread attempts to acquire the lock, then it is suspended till the lock is released. So lock helps in synchronization but solves other problems which synchronized keyword could not solve. For example, we will see in the example forward where read and write lock is used. So what is a read and write lock? So as a construct, it is an interface that specifies the lock that maintains separate locks for read and write access. It enables multiple locks to be granted to the readers of a resource as long as the lock to the resource is not being written. An implementation of ReadWriteLock is provided by reiterant ReadWriteLock. So as in the figure, we will see what is the use case of ReadWriteLock. So in figure 1, there is a resource and thread 1, thread 2 and thread 3 both can read simultaneously this resource. Now in figure 2, when thread 1 starts to write, thread 2 and thread 3 will wait for the writing to the resource to complete, and while writing, other threads which wants to read or write will wait. So this kind of synchronization cannot be achieved using synchronized keyword alone. So here the lock comes into play. Hi guys, welcome to the part 4 of the tutorial on Java and Android multi-threaded programming 3. In this part, we will go through an example where we will use read-write-lock to solve an interesting programming problem. Now we will try to understand lock with the help of an example. So the example will be like this. There will be a list of items for a store, and the prices of the items will be synced from the remote server when the app launches, and then based on the new prices, the invoice for the items will be generated. So let's first create a class called items. Okay, it will have two properties. One is the name and other is the value. I'll create a constructor for both of them and a getter and setter, and also for printing I'll override its toString method, okay, for the pretty print. Now I'll create another class, I'll call it store. The store will have a list of items. Items, and it will have a list of items. Let there be 3 items: chair, table and lamp. have a new item. I'll call it chair, and the value is 20. Then I'll have a new item, calling it table, and have value 15. And then I have a item called lamp. It has value 10. So these are the default items and their values. Now there will be a method that will sync their latest item from the server. We'll call it sync latest price. Okay, we'll define what it will do later. And I will also have a method which will call prepare invoice. Now I want that syncing and preparing of the invoice should be done parallelly. Okay, for running parallel tasks, I'll create an executor service, as you must have understood its operation in the earlier series of this multi-threaded programming. We'll call it private executor service, call it executor, will be executors dot new fixed thread pool executor, and I'll be needing 2 thread in this pool. Okay, now when sync latest price is called, I will run a runnable to the executor. So when I call sync latest price, it will run the executor with a new runnable, and it will make the thread sleep for, let's say, 500 milliseconds. Handle the exception. Interrupted exception E. Okay, so it's like I'm simulating a API call which takes 500 milliseconds, and after that it will change the value of the items. 0 for chair, it will change the value to, let's say, 35. Let's say 15 to 20 changed. The updated lamp to, let's say, value 10. Okay, after that it will just print out the latest value. So I'll create a method that calculate the total value of this invoice. Get total. It will define a variable called total, and then it will loop through the list okay. Now it will add to the total value of item, get value, and finally return the total value. So now I'll just print out the total value of the item after the update. Okay, price hiked, to get total. Okay, similarly for prepared invoice, I will run it in a different thread. Okay, so what it will do is it will calculate the total value of the invoice and just print it. It will show the user your invoice is for the amount with the total. Now this store will send this information of invoice and price data to the caller using a callback. I'll just make it public interface, call it callback. There's two methods on invoice sync. Another method will be on invoice prepared. Okay, on invoice prepared it will just pass in the calculated value. Okay, now this class will receive a callback instance from outside. Okay, now after the syncing it will send the callback on invoice sync. Now after prepared invoice it will again call the callback with on invoice prepared, pass in the get total. I'll save it in a variable where I can use it 2 times. Okay, so this is our store class. It has a list of items. We define their default values, have an executor to run the task in different threads, and a callback to pass the result to the caller thread. First method calls the server and updates the value. Another method prepare the invoice for the user and send the value of the invoice. Now in the main method I'll just comment this out so that I could test my store. Just create main method again. And okay, now I'll create my store. Supply it a callback. Okay, now for the first I'll call to sync the data from the server. Now I'll call to prepare the invoice, and since main thread has called sync latest price and prepared invoice that runs in their own thread, I'll have to keep the main thread alive. So for that I'll create two flags, atomic boolean, call it syncing, new atomic boolean, syncing, I'll set it to true. Similarly I will create another flag for processing. Okay, I'll just keep the main thread alive while these two operations are happening, syncing.get or processing.get. Just keep it running, and after that just terminate and print out the termination message. Call it program terminated. Okay, so I've created a store, and on their callback I'll set their values that it has synced. Similarly, for invoice prepared, I'll call processing is over. So when I run this main program, you see the first I called to sync the data and then to prepare the invoice, but it printed the invoice first and then it says price is hiked. If this was my company, I would have incurred a loss. So in order to synchronize the process where the invoice could be prepared but not when the price is being synced, so do so, I'll create a lock, a ReadWriteLock. Okay, and now I'll create a ReadWriteLock, and it will be reimprint ReadWriteLock. So when sync latest price is called, it will obtain a lock from ReadWriteLock. It will call lock. This is, I'm writing this value, so writing WriteLock. This will be lock dot WriteLock. I will obtain a WriteLock from the reimprint ReadWriteLock, and when I execute, I'll call the WriteLock dot lock, and after the operation is done, I will unlock it. Similarly, create a ReadLock. A ReadLock, when it starts to execute, just lock it, and after the execution unlock it. So I created a ReadWriteLock. When syncing is called, I obtained a WriteLock, and while syncing is done, I called the lock method of that lock, and after syncing I unlocked the lock. Prepared invoice gets a ReadLock. So while sync latest price is writing using WriteLock, the prepared invoice which has a ReadLock will wait till the WriteLock is finished with the processing. So this will make the sync latest price to be called and prepared invoice to wait while the syncing take place, and see what happens. Now this time you see the price is hiked, and after that the invoice is prepared with the correct hiked amount. So this ReadWriteLock help to synchronize the process where the read locks wait while the write lock is doing this work. This is a very helpful lock for syncing procedure that we implement in the Android applications. So in this example, we learned about how to synchronize using locks. So this completes this tutorial example. In the next part, we will cover the summary of our learning. So in this tutorial, we learned that multi-threading is a different way to think about the program, where each component are independent from each other, and at times they need to collaborate themselves to safely make common changes. So these three tutorial series on Java multi-threaded programming will provide the basic infrastructure that we need in order to model our program efficiently and bug-free. So this ends this tutorial series. I hope you have learned something from these series and you will implement and solve your next multi-threaded programming challenge, and you will use the concepts learned from this tutorial. So do like, comment and subscribe to this channel. We will be posting further new updates and tutorials on topics here only. So meet you next time. Bye bye.